So we're preparing for the AP, or preparing for the end of mid-final, right? Whatever. These have to be automatic. That's kind of the point. So derivative of e to the sine x. E to the x, derivative of e to the x, it is the rate of change is equal to the function. It is one of the great functions for us. So e to the sine x is e to the sine x, but it's a chain rule. Derivative of sine x is just cosine x. That's the answer. All right. Everybody on the second one, d dx of the square root of sine x is sine x to the half power. This is a power rule, okay, with a chain rule. The half comes down. You reduce the order by 1. You multiply by the derivative of sine, which is cosine. All right. And again, if I wanted you to, if this was on the AP, it might very well look like this, everybody. I don't take a lot of time in class to go through this. My expectation is we could get from here to here. If that's a struggle, you need to practice a little so you can see that. On my test, you'd be able to stop on the top. All right, everybody, I hate this. This is what, x to the negative 3, right? So this would be negative 3x to the negative 4. And again, just for good measure on the AP, that could be written as negative 3 over x4. That's probably how it would appear. All right. So everybody, parent functions are so important because when you see this, we really should be thinking about the parent function in our head. And if you have to sketch it, sketch it. But here's the parent function 1 over x. All right, and this is shifted 3 to the right. Oh, look at that, stated object. So our asymptote is there. I'm asking you to do the derivative on the right side, right, coming from the positive. So it's obviously going to positive infinity. What would be the limit at x as x approaches 3? Non-existent. What would be the justification for that being 9? The right hand and left hand wouldn't be the same. And that's easy. On the AP, you might have to spell it out. In my class, we would simply write this, right? You would explain that all limits, the left hand and right hand, have to be the same. Last one. All right. We know a fact, and remember, just like doing derivatives, this fact will be on the cover sheet of all tests. What's the limit as x approaches infinity of 1 over x to the n, where n is greater than 1? It is 0, right? This is always 0. If we can get the limit of 1 over x, right? Any number over x, I don't care if it's 3 even, right? That just always goes to 0. That's the fact we got to have at the back of our head. So when we have rational functions, that's fairly easy then, because if I had the limit as x approaches infinity of 2x squared plus 7x over 5x squared minus 3x, does everybody witness right away that this is 2/5, right? It's much more difficult in the purple one. The orders are equal, though. The top has x1. The bottom has x squared inside a radical. And now, even though you can't do this, the sensation now is this. We're going to multiply by 1 over x on the top. And I'm going to multiply by 1 over x on the bottom. But actually, I'm going to turn that to 1 over x squared so I can distribute it to both. So if I ask you to show y, and I'm that kind of guy, it becomes this. Okay? And this goes to 0, right, through the limit laws. The limit can go to all terms, so it's 1 over 1, which is 1, which is wrong. Why? It's not 1. So I'm going to let you look. It's negative 1. Guys, it goes to negative infinity. This is negative, this is positive. You have to make that decision after you find the result here. This is negative 1. All right? Don't miss. That's a tough one, right? And that's a curveball the AP likes to throw. All right, so it's negative 1. All right, so everybody, pause the video because I'm going to go right into the solution if you want to see this. But here we go. The graph of the derivative of f is shown in above. The graph has horizontal tangent lines at x equals negative 1 x equals 1 and x equals 3. At which of the following values of x does f have a relative maximum? Don't get thrown. We don't care about these 3 red points. Because, guys, this is f prime. What do the 3 red lines represent? They represent when f prime prime equals 0. If we're going to find a relative max, what do we care about? We want to know where f prime equals 0. And this is the stuff the AP does. It wants to make sure you understand. So I don't care about those. I care about those. I read the graph because it's f prime. All right, so those are my 3 critical points. -2, 1, and 4. Now, what they want to know when there's a relative max, which we call in my classroom a local max, but we try to use the names, right? This is a local max. So we think about the first derivative rule, and I think about a function that goes from positive to negative. And guess what I get? A local max. So I'm looking positive, negative. Here it goes negative to positive. No. Here it goes what? Positive, positive. No. And what's it do over here? Positive to negative. So what's the answer? Huh? Oh, when in doubt, always get C. You should have stuck when in doubt, always get C. Everybody, this is tough. And it is a huge distractor, right? We talk about distractors of Juda a lot. This is a gigantic distractor. You guys agree? Why would you need those? Second derivative. We want those for concavity. If we're talking about this, guys, this is positive to negative. This is a point of inflection. This is negative to positive. This is a point of inflection. This is positive to negative. These are all points of inflection, but we don't care. They don't indicate maxes. All right.
There's a max. Found one. I win.
You win? Letter C.
No, only that one.
Oh, there's one. All right. Try this one. All right. Everybody. It's a differentiable function. This gives the area under the curve starting at 0 going to x. And then it has h of 6, h prime of 6, h prime prime of 6. So I think I'm going to figure out all 3 values and then compare the inequalities. So I'm just going to estimate h of 6 because I just need it to be ballpark. So I see this and I say, let's call it a triangle. Okay with everybody? It's 6 by -4. I'm going to call h of 6 approximately in my head -12. All right, everybody? I mean, it's a horrible estimate, but if the numbers aren't close, it won't matter. You guys agree? So I'm going to write that up here and erase that because I need to have the space. Big negative number is what it really is. All right. Now I have to take the derivative. The derivative of h of x is h prime of x. Again, if you're integrating a function and then taking the derivative, the fundamental theorem of calculus tells us that derivative of an integral is simply the function. Right? The derivative of an integral is simply the function. And since the chain rule here, what's the derivative of x? 1, right? So it'd be times 1, but we don't care about that. So now if I find h prime of 6, it's equal to f of 6. Well, what is f of 6 on the graph? 0. You just read the value, everybody. F of 6 is 0. So I'll go over here and say h prime of 6 is exactly 0. I don't have to do approximate. It is 0. All right, last one. I'm going to erase this. What's the derivative of h prime? H prime prime. What's the derivative of f of x? F prime of x. So if I go h prime prime 6 equals, this is where it gets so hard. I get that this is difficult as students learn. For h prime of 6, you read the value of the graph. What am I having to do at h prime prime of 6? We're not reading the value. We're looking at the shape. So everybody, I don't know. Do you agree that's a tangent line at 6? Should we call it positive 1 maybe? Ish? Does it matter really what it is? And the answer is no, because if you think about it now, you know that h prime prime 6 is positive. You know h of 6 is negative, and you know h of 6 is 0. H prime of 6 is 0. So I need H prime in the middle, I think. This is 0. Oh, look. Guess what? The very first one is true. And now, just to make sure I didn't screw up, H of 6 here is negative 12. H prime prime is 1. Nope, that didn't work, right? And if I go through the rest, I can make sure if I had extra time on the AP that the rest of these are wrong. Everybody, the real skill for us, especially as we get ready for our next exam, is the ability to estimate these values. This is not easy. This is not easy. This is chapter 5 in Stewart, 5354. Okay, we're running. I'm going to put up another one here. All right. So everybody, this is an integration. You have the differential equation, but they want the original condition. And if you look at the answers, you can see that it's an antiderivative. And if it helps you to make you feel better, because I like you guys to feel good, you could put the differentials with parts. What's the antiderivative of dy? Y. What's the antiderivative of 2 sine x? It has to be negative 2 cosine x, right? Because you think derivative of cosine is negative sine. Then we got to have plus c. We use the initial condition. 1 equals negative 2 cos pi plus c. We know from our unit circle in pre-calculus that 180 pi is 180 degrees. Negative 1, 0, cosine is x, so it's negative 1. So I get 1 equals negative 2 times negative 1 plus c. 1 equals 2 plus c minus 2 minus 2. Negative 1 equals c. The answer is B. Everyone, I would simply take the derivative of these functions. Hopefully you recognize right away that the derivative of cosine is negative sine. That's not negative. You can immediately cross out A and B. And then for the C, D, and E, you just have to use the initial condition to see which one of these three actually works with putting in pi and getting positive 1. The AP does not care which way you do it. Pick the method that works best for you. Personally, when I have multiple choice, I work from answers when I can versus doing it the other way. Keep practicing. AP's coming.